Hello everyone, welcome back to our channel Problematical. Today we'll continue with the exercises of sets. We already completed 1.1. Let's start with 1.2 today. The first question is, which of the following are examples of the null set? Now, what is a null set? A null set, also represented by 5 or empty braces, is a set with no elements. So, let's convert these conditions, these following examples, into rooster form and see which of these values contains an element. First part, let A is equals to given set. Therefore, it's given that A is a set of odd natural numbers divisible by 2. Now, A is a set of odd natural numbers. On the number line, we have natural numbers starting from 1 to infinity. So 1, let's consider only odd numbers, 3, 5, 7, 9, etc. But you have to have those odd natural numbers which are divisible by 2. None of these values are divisible by 2. For something to be divisible by 2, your remainder should be 0. If you divide all of these by 2 or any of these by 2, you get a remainder 1. So there is no such element present. Hence, A is a null set. 2. Set of even prime numbers. Again, let's consider number line. But let's represent all the prime numbers on the number line. Prime numbers, 2 is the smallest prime number. 3, 5, 7, 11, and so on. These are prime numbers. Out of these, 2 is the only prime number which is even. So your B set will be a set with with only a single element. It is a singleton set with element 2. Hence, this is not a null set. 3. X is a natural number. X is less than 5 and X is greater than 7. Again, let's draw the number line. On the number line, your X value has to be less than 5 and greater than 7. So the numbers 5 and represented are over here, 5 is over here, 7 is over here. Let's broaden the area where these two conditions states. X is less than 5. So X is any value on the left hand side of 5. Or X is greater than 7. X is any value which is greater than 7. There's an AND written in the middle. AND represents that both the conditions should be true. But you cannot have any element which is present in both the regions. Or there is no overlap in the two regions. So it is a null set. There is no such element which lies on the left hand side of 5 as well as on the right hand, as well as the same number on the right hand side of 7. So this is a null set. Next, phi is a point common to any two parallel lines. Now, if you have two parallel lines, A and B, how many points are common in these two lines? No points are common. That's the definition of parallel lines. They never meet. They go hand in hand. They have a shortest distance is a perpendicular distance, which is constant throughout. So here also it will be a null set. So out of these 4, only second is not a null set and the rest 3 are null sets. Next question. Which of the following sets are finite or infinite? First, set of months of the year. Now, what is a finite set? Finite set is a set whose numbers can be written in rooster form, irrespective of the number of elements it holds. It has to be a finite number. It has to be a number which is countable. It cannot be an infinite number, because if it is an infinite number, then it will be an infinite set. The set of months of a year, you can clearly mention Jan, Feb, March, April, Now, no one has asked you to mention the set, but even if you write it, we know that number of elements of set A is equals to 12, and 12 is a finite number. Hence, A is a finite set. Second, your B is 1, 2, 3, and so on. By observation, you have that it is an infinite number of natural numbers. It will continue till infinity. So B is a set of natural numbers, or all natural numbers. Therefore, B is an infinite set. Next, 1, 2, 3 till 9900. So C is a set of elements which are ending somewhere. So C is a set of natural numbers from 1 to 100, or you can say that n of C is equals to 100. Therefore, C is a finite set. Next, a set of positive integers greater than 100. D is a set of positive integers, but integers which are greater than 100. If we draw a number line, and if this is 100 over here, so you are supposed to consider all the positive integers which are greater than 100. Right? That's what's given in the question. Now we know that there are infinite numbers as such. From 100 till infinity, you can have these infinite numbers of elements in the set. Hence, D is an infinite set. A set of prime numbers less than 99. Let us consider E as a set of prime numbers less than 99. So, prime numbers start from 2, and you have to consider them less than 99. So, they are ending somewhere. That means here E will be a finite set. Expression. State whether each of the following sets are finite or infinite. First, a set of lines parallel to x-axis. So if you have your x-axis and y-axis, we know that by observation, you can draw infinite lines which are parallel to x-axis, because there are infinite points on y-axis. So you can have one line passing through each of these infinite points on the y-axis. The equation of any line parallel to x-axis is y is equals to c. C can hold any point or any value on the y-axis. So first is an infinite set. Second, set of letters in English alphabet. We know that there are 26 letters in English alphabet. Therefore, it is a finite set. Next, set of numbers which are multiple of 5. Numbers which are multiple of 5. So they haven't mentioned that the numbers you're supposed to consider are natural numbers or rational numbers or irrational numbers. In any set, the numbers which are multiples of 5 would be infinite in nature. However, when you say multiples of 5, you need We'll only imagine it as natural numbers if nothing is given. This is an infinite set. Fourth, set of animals living on Earth. Now, we know that there are many animals living on Earth, but in biology, certain kind of creatures are only named as animals. And even though it seems to be an impossible task, someone might be able to count these numbers. No matter how big the number is, it is countable. You can say that this is one animal and this is second animal and this is a third animal. There isn't a 1.5 animal or 2.5 animal. So it is a natural number, the result that you're going to get, and it will be a very big number, but it is countable in nature. There are not infinite numbers of animals living on Earth. There are only finite number of animals living on Earth. So it is a finite set. Next, the set of circles passing through the origin 0, 0. Now, circles which are passing through the origin 0, 0. So let's draw your x and y axis. This is your 0, 0. Now, we are not mentioned here what is the radius of the circle. So the circle can be anything. All you need is it should pass through your origin. It can be in any circle which is passing through your origin. Infinite circles, in this case, can pass through your origin. We do not know which one. We do not know whether it's touching your other axis or not. We do not have any idea about the radius, but all we know is it is a circle which is passing through your origin. So obviously it will be an infinite set. Next, it will in the following state whether A is equals to B or not. Let's observe A and B. Now, two sets are said to be equal if they have equal number of elements, if there is no repetition of elements in each of the sets, and if they are one-to-one correspondent or correlated with each other. That means every element of A should be present in B, and every element of B should be present in A. In terms of sets, we say that A is equals to B if A is a subset of B and B is a subset of A. If both these conditions are satisfied, only then we can say that A is equals to B or vice versa. So let's see A, B, C, D. This first element of A is present in B. Second element B is present in B. Third element C and fourth element D. Both n of A and n of B are 4 in number and no elements in each of the sets are repeated. Hence, we can say that A is equals to B. Second, A is equals to 4, 8, 12, 16 and B is equals to 8, 4, 16, 18. Now, if you observe 4, 4 is common, 8, 8 is common, 12 is present over here, 12 is not present here, 16 and 16 is common and 18 present in B is not present in A. So here you can see that 16 is an element which belongs to A, but 16 does not belong to B. Similarly, 18 belongs to B, but 18 does not belong to A. Therefore, we can say that A is not a subset of B and B is not a subset of A. Therefore, A is not equals to B. Next, A is equals to 2, 4, 6, 8, 10 and B is a set of all x such that x is a positive in even number and x is less than equals to 10. Your first set is given in roster form and the second in set builder form. Let's convert the second set into roster form. A is already given to B, 2, 4, 6, 8, 10. You can mention B as it is from the question and then convert it into roster form and by observation. X is a positive integer and x is less than equals to 10. It's a positive integer. So on the number line, you're only supposed to consider integers which are on the right hand side of your origin. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's given that x is less than equals to 10, which means that you are supposed to consider 10 in your discussion. So the values under consideration would be 1 till 10. There's a second condition, x is a positive even number integer. Out of these, only positive integers are to be considered. Positive even. Positive numbers are present over there. Even would be 2, 4, 6, 8, and 10. Let's write them as set 2, 4, 6, 8, and 10. These two look exactly same. 5 elements in each, and each element is present in the other. So A is equals to B. Next, x is a multiple of 10. So here you can say that A is a set of multiple of 10. 10, 20, 30, 40, 50, and so on. And here B given to you is 10, 15, 20, 25, 30, and so on. Clearly, your 15 is present here, but 15 is not present here, and 25 is present here, but 25 is not present here. So that's the justification which you'll give, that 15 belongs to B, but 15 does not belong to A. 25 belongs to B, but 25 does not belong to A. Therefore, A is not equals to B. Next, are the following pairs of sets equal? So you have to check whether the set of pairs are equal or not. If there is something mentioned, a set mentioned in set builder form, you should convert it into roster form. Roster form. A is equals to 2, 3 given to you. B is equals to set of all x such that x is a solution of this equation. The equation given is x squared plus 5x plus 6 is equals to 0. Now you can use middle term splitting method. 6 divided into 2 parts such that addition is 5. 2 into 3, 2 plus 3 is 5. So x squared plus 2x plus 3x plus 6 is equals to 0. Common x plus 2 plus 3, x plus 2 is equals to 0. X plus 3 into x plus 2 is equals to 0, which means x is equals to minus 3 or x is equals to minus 2. As you can see, here the elements would be minus 2, comma, minus 3. By default, these two are not equal. A and B are not equal. Therefore, A will not be equals to B. Second, A is a set of all x such that x is a letter in the word follow. So, A is equals to F, comma O, comma L, comma W. O and L are repeated. We will only mention them once. B is a set of all the letters in full. W, O, L, F. W present in both O, L, F. No repetition of words. Number of elements in each is 4. Definitely A is equals to B. Last question. Find the sets given from the sets given below. Select equal sets. First, you have all sets are given to you. You have to find equal sets. That means you have to compare and see which sets are equal. This can be done by observation. All the sets are given in roster form. All you have to do is compare the elements of the set. 2, 4, 8, 12. So let's see which sets have 4 elements. A, n of A is equals to n of B is equals to n of C is equals to n of D is equals to 4. These have 4 elements. N of E is equals to n of F is equals to n of G is equals to n of H is equals to 2. So either you'll get equal sets here or you get equal sets here. Let's compare A and B. 2, 2, 4, 4, 8 and 12, 1 and 3. Definitely A is not equal to B. A and C. 2 is present here in A, but 2 is not present in C. A and D. 8 is present in A, but 8 is not present in D. Forget about A now. Let's start with B. 1, 2, 3, 4 and compare it with the rest. Not with A because we've already done that. 1 is present in B. 1 is not present in C. 1, 2, 3, 4. D is 3, 1, 4, 2. 1, 1, 2, 2, 3, 3, 4, 4. By observation, you can see that in this set, B is equals to D. Lastly, you're done with B now. C. C should be compared with D. You have 8 over here. 8 is not present in D. So C is not equals to D either. So your A is not equals to B. Your A is not equals to C. Your A is not equals to D. What did you do? You took only one element, one set, and compared it with the rest. And then you forget about A. You start with any one of these. Let's start with B and compare it with the rest, not with A anymore. B is not equals to C, but B is equals to D. C, then forget about B. You're left with C and D. Compare them. By comparing, we found that C is not equals to D. Next, E, F, G, and H. -1 and 1. Compare it with F, you have 0, A, and definitely not. With G, 1 minus 1, your E is equals to G. So E is compared with F, they are not equal. E is compared with G, they are equal. E is compared with H, they are not equal because you have -1 in E, which is not there in H. F is compared with G, they are not equal. 0 is present in F, not present in G. F is compared with H, not equal because H has 1, F doesn't. Then compare G and H, they are not equal. So the only two pair of sets that you found equal were B is equals to D and E is equals to G. That concludes this exercise. We'll continue in the next class. Thank you.